Hi, so today in this video we're going to be going over 1015, chapter 2.4, transformations of a linear function. And this is a very, I feel like this is a very important video because these transformations are very similar throughout all functions. It just looks different from function to function, but it's about the same principles. So I will go over it as best I can. It could help if you go watch chapter 1.3, transformations and the inverses of functions. That will go over some of the transformations, but we'll see how they apply here to graphs because they were just modifying little points on a graph. So we have our function f of x, and it's shown on the plot. We want to graph the function f of x after it has been vertically shifted down 5 units. So let me just copy this. If we're vertically shifting it down, here's our center. We want to shift 1, 2, 3, 4, 5. The slope stays the same, and we are just moving it down 5. The function f of x equals x is vertically shifted up by 5 units. The point 3, negative 3, negative 3 is transformed to become what point? When we are shifting up by 5, we are just going to add 5 to our y, right? So we'll have negative 3, 2. Select the correct transformation of the function f of x equals x to the function f of x equals 3 over 10,000. So this one is daunting because of how it looks. But basically what we can do is we can approximate what this value looks like. We know that it's not going to be a vertical stretch of this. It's because we're compressing. This is our answer. We're compressing it by 3 over 10,000. So to help graph though, one thing that we can do is say, okay, what about is this? Like this is about 3 over 10, right? Wait, let me think for a sec. Okay, so what I'm going to do is I'm going to plug this into my calculator. 3 over 1,000, 10,000 I mean. That's going to give you 0.333. And that's, an extra 3. That's very similar to 1/3, right? 1/3 is 0.33333 repeating, right? So we can just assume, we can just sort of treat the slope as if it's 1/3 now. Since we're stretching, we don't need to move our x-axis, but now we can say this is about 1/3, right? So we'll go up 1 over 3. Oh wait, whoops, sorry, hold on. 1 minute. Sorry, okay, my bad. We actually have the thing on top. 1 minute. Okay, sorry. This is a little bit like crazy with how we're supposed to graph it because we can't go up 3 and over 10,000. So we have to like make educated guesses. So yeah, we're going to have to go up 1 over 3 because it's about 1/3, right? And this would be our new 1 over 3. This would be about our new graph, and that's what you do. Sorry, that was I was over the place with that. What I recommend is like seeing if you recognize a pattern. I would plug that into your calculator if push comes to shove, and that will turn it into this, and you can times that by x and get about the like 1 or 3, whatever works best. Like you just basically have to find another point for it, and you can approximate. So, and then yeah, it's compressed. Sorry, that one was confusing even for me, I guess. The function of f of x equals x is vertically stretched by a factor of negative 3. The point negative 5 is transformed to become what point? So basically, we need to times our y value by this negative 3. So we have negative 5. Negative 5 times negative 3 is 15. So this is our new point. Sorry, I'm trying to speed through this. The function f of x is equal to x is vertically compressed to 1/5 of its height. The point negative 2, negative 2 is transformed to become what point? Basically, we will divide this by 5. So we have negative 2, negative 2 over 5. Boom, boom, done. Don't forget that negative. Write the function that is the result of the transformations performed on f of x equals x. Write your answers in the form of f of x equals mx plus b. So f of x equals our slope is going to stay the same. Well, it's reflecting across the y-axis, and if you remember that, we just minus our x for that, right? And then shift it up by 8 units, so plus 8. And then, hold on. Yeah, okay, so we'll have negative x plus 8. And then, x is shifted down by 9 units, so we'll have f of x equals x minus 9. Match the equations of the transformation of f of x equals x with the descriptions of the transformation. Compressed by a factor of negative 5, so we're dividing by negative 5, right? And then stretched, we're multiplying by 3. Stretched by a factor of negative 5, we're multiplying by negative 5. Compressed by a factor of negative 4, we'll divide by 4. Graph the function f of x equals x after it has been reflected across the y-axis. Basically, we're saying, okay, we see this y-axis, we're going to flip. So we're going to say this way instead. Bloom, 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 bloop, like that. And then the equation of the new function, we don't have, our y-axis is still 0, so we'll have f of x equals negative x, since we're reflecting, and then just negative x, yeah. Use transformations. F of x equals x to graph. F of x equals negative 1/2 x plus 2. Like I said, it's really useful to think about this. We have our y-intercept, which is 2. And then we go down 1 over 2. Down 1 over 2. Like this. Yep. So, bloom, bloom. And that's what all you need to do for that. Yes. Sorry, I'm speeding through it. I don't know if I'm doing it justice. Basically, yeah, we're just moving stuff around, and these principles will stay the same. Like if you give your x a minus, a negative, it will reflect it over the y-axis. You can shift by multiplying and compress by dividing, and move it around with addition and subtraction. So match the equations of the transformation f of x equals x with the descriptions of the transformation. Shift it up by 4 units and vertically compressed to 1/5 of its height. So we're shifting up, so this plus 4 gives it away. We don't even really need to look for that 1/5 there, because we know that there's none other that are plus 4. Stretched by a factor of 2 and vertically shifted down by 2 units. So down 2, it's going to be this one. Vertically stretched by a factor of 5 and shifted down by 4 units. So minus 4. And then vertically compressed to 1/4 of its height is going to look like this. Yeah, I know I went through that quickly, even though it's still like a 10, it's not 10 minutes, it's like 8 minutes video. If you have any questions, please let me know. I can also make a more in-depth video if you'd like eventually. I think it'll be useful around the time that we get into parabolas and stuff like that. But yeah, just let me know if you've got any questions. Have a good one.